now that we've had a chance to look at the unit circle and just explore kind of what the values involved are, I think it's important now that we take a look at how we use the unit circle to identify relationships between sine, cosine, and tangent. So I'm going to look at this first quadrant here, and specifically I'm going to look at this reference angle, the 30-degree reference angle. And so I'm going to redraw that little triangle here. So we have our 30-degree angle, our 60-degree angle, and we have our long leg of square root 3 over 2, a short leg of 1/2, and a hypotenuse of 1. So let's take a closer look at that triangle and remember our trig values. So remember that the sine of any angle, in this case 30, is the opposite length divided by the length of the hypotenuse. In this case, the opposite length is 1/2, and the length of the hypotenuse is 1. Since anything divided by 1 is equal to itself, 1/2 divided by 1 is 1/2. Our cosine of 30 degrees is going to be the opposite divided by the, not the opposite, divided by the hypotenuse. I was just reading what I wrote above. The length of the adjacent side divided by the length of the hypotenuse. The adjacent side has a length of square root 3 over 2, and the hypotenuse again is 1, so that simplifies to square root 3 over 2. So we've got a sine of 1/2 and a cosine of root 3 over 2. Now if I take a look at my unit circle, I should notice that some of these values actually look a little bit familiar. My sine value is the y coordinate of that point, and my cosine value is the x coordinate. Let's take a look at another triangle here. Let's take a look at our 45-degree angle. And again, I'm going to redraw this. So my legs are root 2 over 2, and my hypotenuse again is 1 because it is the unit circle. So again, I'm going to calculate my my sine of 45, and in this case, I'm looking at this angle down here, since that's the interior angle right off the center of the circle. So my opposite is root 2 over 2. My hypotenuse is 1, which simplifies to root 2 over 2. My cosine is root 2 over 2, that's the adjacent side, divided by 1, which is again root 2 over 2. Now, maybe this one doesn't seem so obvious, right? Because both of our x and our y values are root 2 over 2. But clearly there's a relationship now going on between those coordinate points and the sine and cosine values. And so what that relationship is according to the unit circle, those coordinate points that we identified previously tells us that the cosine of a value is equal to the x coordinate. So the cosine of any angle theta is equal to the x coordinate, and the sine of any angle theta is equal to the y coordinate. Now, a little piece of advice here, and I'll tell you from a perspective when I was a student, excuse me, I always mix this up. So our coordinate points we know are x and y, and for some reason, I don't know if it's because of SOHCAHTOA, maybe it's just me, but I always want to do sine before cosine. But be really careful here because our x coordinate is actually the cosine of theta, not the sine, and our y value is actually the sine of theta, not the cosine. So just like slope is a little bit in reverse, so is the cosine and sine of our coordinate points. Last but not least, if I want to find the tangent of any angle here, remember that tangent is defined as sine over cosine, which means I can simply take the y value and divide it by the x value. So long story short, the unit circle makes it really easy to identify these trig values for certain angles, or in particular, these angles here. So let's do just maybe another example here. Let's use the angle 150 degrees. So I'm going to find the sine of 150 degrees, the cosine of 150 degrees, and the tangent of 150 degrees. So the sine of 150 degrees is our y coordinate, and the cosine of 150 degrees is our x coordinate. So again, it's a little bit backwards from maybe it's just me. So my sine of 150 degrees, according to our unit circle, is 1/2. Our cosine is negative √3/2. And then our tangent, remember we take the sine and we divide it by the cosine. So that would be 1/2 divided by negative √3/2. And remember, dividing by a fraction is the same as multiplying by the reciprocal. So 1/2 times negative √3. Oops, I was writing it just exactly the same as it was. Negative 2 divided by √3. The reciprocal is writing the fraction. The denominator and numerator switched. And when I get that, my 2's reduce and I'm left with negative 1/√3. Now, do you remember that convention we talked about in an earlier video, right? Is we're not allowed to leave a radical in the denominator. So while our sine, our cosine look great, we still do need to continue to rewrite this just a little bit. And remember, we do that by multiplying by a fancy 1, so that radical divided by itself. And so I get negative √3, negative 1 divided by the square root of 3 is negative √3, and √3 divided by √3 is the square root of 9, which is 3. So my tangent is actually negative √3/3. So we're kind of involving two short processes here. The first is identifying those relationships between the unit circle and the trig values. And then the second is just a little bit of that manipulation and rewriting our radicals. So give this a shot. There's some practice questions down below. Please try your best. Please check your answers and please ask questions if you have them. This is all new material and this is the time when questions are going to start coming up. So do your best. You're awesome. Hang in there and I will talk to you later.